Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a full stack blockchain application. Alright, so in this video we're going to go ahead and get our project set up so we can start coding. So before we do that, be sure to subscribe to this channel if you haven't already. Click the like button down below. And as always, if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, so the first thing we want to do is just set the project up. We want to make sure that our environment's configured properly, that we can talk to the blockchain and start coding without any problems, okay? So instead of, creating a bunch of files ourselves, I want to get started with a starter kit, okay? And this is something I created to allow you to create dApps quickly or blockchain applications without having to write a bunch of code yourself, right? I don't want you to have to do a ton of configuration. So basically, you can just copy this URL. This is github.com/dappuniversity/starter kit and clone the project this way, all right? So if you're not very comfortable with Git, you can also just download a zip file if you want to right here, but I'm gonna use Git, okay? So I'm gonna go to the terminal, and I'm going to say git clone. I'm going to paste in the URL. And I'm also going to provide the project name that I want to create. So in this case, it's going to be marketplace. Say marketplace. All right. Okay. So now I can change directory, cd marketplace. All right. All right, and there we go. That's our new project. So I just cloned the starter kit and created a new folder called Marketplace, and that's where we are. So I can see all the files inside of here, and I can see, that there's Git information here. It comes with an initial commit, but that just sets the project up, so that's okay. So I'll clear all this out. Now I'm going to open this in my text editor, okay, to take a tour of the project. I'm going to use Sublime Text, and I can open files in projects with Sublime Text with this special symlink, say subl dot. If you don't have that, configured on your computer, that's okay. You can just manually open the project in Sublime Text yourself. But that's how I do it. All right, so let's take a look at what we created whenever we downloaded that starter kit. Okay, so this is a truffle project. All right, you could have created something very similar to this with the truffle init command, but I've set this up, with some dependencies already. We've got a bunch of JavaScript dependencies in here inside this package.json file that we can use for testing, that we can use to just navigate our project really quickly. We've already got React installed, which is what we'll use to build the client-side application. We've got Bootstrap installed so that we don't have to write a bunch of CSS ourselves and can create really nice looking front ends. So this is designed for you to start creating full stack blockchain applications really quickly, right? And I've also got the network configuration ready to go. We're already talking to Ganache, our local blockchain, without any configuration. And you'll also see that I have some additional configuration here to put the smart contracts in a different place than they normally are in a truffle project. And there's several reasons I do that, but basically, I'm going to keep all of our source code inside of this source code directory. So long story short, if you're familiar with other truffle projects, just know that the smart contracts are going to be in a different location than they normally are. But that's not a really huge deal. It just helps keep things a little more organized, especially for deployments. Okay. So we can take a look, inside the source directory, we're going to have our React components that we'll use to build the client side, but we'll also have the smart contracts, which will essentially be the backend for this project, all right? So inside the smart contracts directory is where we're going to create our first smart contract. We can already see that there is a smart contract inside of here. This is actually just a smart contract that ships with truffle projects. This is a contract that handles migrations. So whenever you put new smart contracts on the blockchain, Truffle uses this smart contract to help do that. All right. So let's go ahead and create the smart contract that we're going to write in this tutorial series inside this directory right here. So I'm going to create a new file. All right, and we'll create it in this same folder, and we're going to call this Marketplace. So capital M-A-R-K-E-T-P-L-A-C-E, all right, .sol, S-O-L. All right, and this is the file where we'll write all the Solidity source code for the smart contract. So the first thing I want to do inside of here is declare the version of Solidity that we're going to use. All right, we do that like this. Say pragma, Solidity. All right, and then we use a caret. Say 0.5.0, all right, and then follow that with a semicolon, all right. Next, we declare the smart contract We use that with the contract keyword, say contract, and we're going to call this marketplace, just like the file name. All right, and this is going to be the smart contract that handles all of the business logic for buying and selling items on the blockchain. Right, and it's also going to write to the blockchain and read from the blockchain. So it's going to kind of act like our all-in-one backend for this project. Okay, so we put all the code for the smart contract inside these curly braces like this, and inside here. And the first thing I want to do is essentially just create a way to make sure that this smart contract gets deployed properly to the blockchain. I don't want to write too much source code inside of here. I just want a simple check. Okay, so what we're going to do is give our smart contract a name, and we'll check for that name inside the console. Okay. So we do that like this. I'm gonna create a variable called name for this, but it's a special kind of variable, right? It's called a state variable. So why is a state variable special? Well, the state variable essentially writes information to the blockchain. The value of that variable is actually stored on the blockchain, all right? And it kind of belongs to this entire smart contract, kind of like a class variable would in maybe another object-oriented programming language. And we, just declare state variables like this. First, we declare the variable type, all right, because Solidity is a statically typed language. So we say string, all right, it's going to be a string. And then we follow that with the variable name like this. We say name, all right. And that's not this is just the actual name of the variable is name because that's what we're going to do. We're going to set the variable name, okay? So that's how you create a state variable. Now, the next thing we want to do is be able to access this variable from outside the smart contract, okay? So right now, we could, update this value and it would write it to the blockchain and we could read this from the blockchain, but currently we can only read this value inside the smart contract itself, right? We want to actually be able to access it from outside, so we declare it public. And this will actually create a function for us where we can, call the function name that will return this variable value whenever we deploy the smart contract, okay? So next, we actually want to set this value. And there's several ways we could do that. I'm going to do it inside of the constructor for the smart contract, really just to show you how the constructor works. Like I said, there's a couple different ways you could do this, but I'll just show you this way. All right, so let's do it this way. We'll say constructor. All right, and this is how you create a constructor. So constructor is basically just a function inside of Solidity that gets run only one time whenever the smart contract is deployed, all right? So let's say constructor public, all right, and this is going to be where we set the value. We'll say name equals, say Dapp University, marketplace, all right? There we go. So that's how we set the value of that name, okay? And we do this inside the constructor function, which we call constructor. And let's go ahead and see if this works. So I'm going to open up the terminal, go back here, and let's first compile the smart contract just to make sure we don't have any errors in the code. So we say truffle, compile, like this. Oh, looks like we got an issue here. I see what the problem was. So first, we didn't actually install the dependencies for our project, okay? So we cloned the project, but we didn't actually run npm install. And I'm actually going to leave this in the video because this is a common problem that people run into. So I want to go ahead and fix it for you while I'm on camera. So all these packages inside of here we haven't installed yet. So make sure you do this whenever you clone the project. We'll say npm install, just like that. And I'll just pull this up in case it's getting cut off at the bottom of the screen. We'll wait for all these to download. And you're probably going to see some errors here at this time. I'm trying to figure out what's going on here. It should install successfully even if you see errors. You can probably just ignore them. Just make sure that you see a success message at the bottom of the screen, okay? So here's what I'm talking about. You're starting to see this kind of stuff. Don't worry about that. As long as your build actually succeeds. Okay, so you can see right here, it says optional skipping this, right? Skipping these optional dependencies, don't worry. As long as you see this, you're okay. All right, I haven't run into issues successfully building the project with those errors, okay? All right, So I'll clear that out, and we'll try truffle compile again. We'll say truffle compile. All right, it worked. And now you can see that it actually put the compiled smart contracts in the correct place. So I'll just show you where that is. All right. So we put it inside the source directory under this ABIs directory, and we can actually see the compiled smart contract here. This is an abstraction that Truffle creates. It has an ABI inside of it. I suppose this could be named something a little better because this file actually is more than just an ABI. Here's the ABI. ABI stands for Abstract Binary Interface, and basically just describes how the smart contract works with JSON like this. But we can also see the byte code for the compiled smart contract, lots of other stuff. Okay. So that worked, and this is where the ABIs go inside the project, all right? So the next thing is to actually deploy the smart contracts to a blockchain. We'll do it like this. We'll say truffle migrate, all right? And we can also, actually first, let's just make sure we have Ganache running. So that's something that you all will want to do. Say Ganache, all right? Wait for this to open. Mine opened off screen here. So let's actually create a new workspace. So what I'm going to do is I've got an old one here. So let's kill that. Remove it. All right, new workspace. We'll say marketplace. And what you want to do is add your truffle project. So we can go to add project. All right, so I found marketplace, and inside of here I just want to select the truffle config file. So essentially what this is going to do is link your project to Ganache, and it'll show you extra useful event data, stuff like that, whenever you're trying to debug or just watch stuff happen on the blockchain. Okay, so we'll add project. We'll save workspace. All right, and there you go. You got your blockchain running. That's something you want to make sure you do before you try to migrate your smart contracts, because it won't be successful if you're not connected to Ganache. And you want to double check that port 7545 is where Ganache is running, because that's what you specified here in truffle, your truffle config file, so 7545. Okay. All right. So let's run the migration. So truffle migrate, hit enter. All right, it worked. So now let's just check. I'm going to clear this out, and I'm going to open the truffle console. Okay, I do that like this. Say truffle console. So now you've opened the truffle console, which is essentially just a JavaScript runtime environment that allows us to interact with our blockchain. Okay, and we can interact with smart contracts and just the blockchain itself. Okay, so inside of here, we have access to Web3, which is the main JavaScript library for communicating with the blockchain. So I'm going to pull this up in case it's getting cut off on the screen. We can see the accounts that are listed with Ganache. We can say Web3. ETH or ETH, get accounts. And we say that like this. We can say accounts equals await Web3 ETH get accounts. All right, enter. And it'll say undefined, but that's just the return value. That's not actually what got assigned to accounts. Or that's what gets logged out. So we say accounts. All right, and now we can see all the accounts that are running in Ganache. So if you go back to Ganache, that's the same thing. All right. And now we can, also do really simple stuff like await, say block number, say await Web3 ETH get block number. All right, block number. All right, that'll just show you the current block number on the blockchain, right? There you go. So that's the way to just assume that you are actually connected to the blockchain, because you can get the block number, you can see the accounts. And so that way you're talking to Ganache correctly. You're actually talking to the blockchain. You've set that up well. And so the next thing you want to do is actually just check the smart contract. So we can get a copy of the deployed smart contract like this. We can say marketplace equals capital M marketplace dot deployed. All right, I'm going to call that function. And this actually isn't going to work. I can see it ahead of time, so we'll go back and fix it, but we'll say await. And we'll say marketplace. All right, so marketplace has not been deployed to a detected network. All right, so I just realized this was going to break before I tried it. So let's see why. All right. So I'm actually going to leave this in the video. I'm kind of glad it's happening this way, that I'm kind of forgetting to do some things, because it shows you that you can read the errors and then figure out, why this error is happening and what you need to do differently to fix it. And that's kind of really how development works in the real world. So I'm going to X out of the console, and I'm not going to leave you, scratching your head as to why this is happening. I'm just going to tell you. So we didn't actually migrate this smart contract to the blockchain yet, all right? So I'll tell you why. We actually have to create a script to do that, all right? So we see this migrations directory here. You see an initial migrations file. I'm going to create a new one, and I'm going to call this 2, all right? And we'll say deploy contracts.js. All right, so this is 1 and then 2. And you actually need to order these so that Truffle knows the order to run them in. So 1 is the initial one, 2 is the one that we're going to create. So I'm just going to copy all the code inside of here and paste it. And I'm going to change all the words that say migrations, and I'm going to call it marketplace. All right, so that's pretty simple. This file basically just takes the smart contracts and puts them on the blockchain. This is very similar to a migration in other contexts. If you've ever worked with like a database before, had to create migrations to add new columns or tables or something like that. It's essentially what this is. It's migrating the database from one state to another. This is migrating the blockchain from one state to another by putting a new smart contract on it, okay? All right, so let's rerun our migrations. So truffle migrate. And do this again. All right, now let's open the Truffle console. All right, now let's try this again. We'll say marketplace equals await, capital M marketplace, dot deployed. All right, so set undefined. That's okay. We didn't actually return the value of the variable. We do that like this, a marketplace. All right, there we go. So now let's get the address. Say marketplace address. All right, there you go. The smart contract actually has an address, so that's good. Now let's check the name that we set up here inside this state variable. So do that like this. We'll say name equals await, capital M, or sorry, lowercase m, marketplace, name, call the function. And this was the function that was created whenever we declared this state variable public, right? All right, so await name. And then we'll return name like this. So just say name. Boom, there you go. Dapp University Marketplace. Awesome. So it worked. We successfully put this smart contract on the blockchain. We've been able to fetch the address, and we've been able to fetch the name. So that's a good smoke test to make sure we got everything set up properly. All right. So that's good. Now, the next thing I want to do just to finalize this smoke test is to create a basic test file that we're going to fill out during the rest of this tutorial. We'll kind of do this in a somewhat test-driven fashion, or at least we will prioritize writing tests as we create this marketplace smart contract. We'll write tests alongside the Solidity source code, right? So we can write tests in JavaScript inside this test directory. Actually, I don't see one. So we'll have to create one. So I'll go to the terminal like this and say mkdir. So that stands for make directory. We'll say test. All right. So we can see a new test directory was created here. And let's just touch. That'll create a new file, test. And we'll say marketplace, capital M, marketplace, test.js. All right. Clear all that out. And inside of here, we have an empty test file. All right, so what I want to do is fill this out and basically check for the same thing we just did in the console. We essentially just want to, check that the contract was deployed to the blockchain, has an address, and has a name. So we can import the contract into this test file like this, pretty basic. All right, we just say marketplace, constant marketplace equals artifacts require marketplace.sol. It's a lot like the migration file that we just saw a minute ago, right? Same thing, almost verbatim. And next, we can use Mocha and Chai, which comes with Truffle, okay? So I'll actually just show you that. So Mocha is a testing framework in JavaScript, and this is what comes bundled with Truffle. And Chai is an assertion library that allows you to do assertions in your test, like should, be, expect, assert, things like that, right? So that's what we're going to use for this. And we can declare the test for the smart contract like this. We'll say contract. We'll pass in marketplace. All right, and then I will pass in a function. This will be the accounts. All right, and then I will use some curly braces here. And we'll put all the tests inside of here. All right, so the first thing we want to do is create a before. Well, let's do this. Say let marketplace. So we'll do lowercase. And this is where we'll store the deployed smart contract with this variable, but we're going to declare it at the top because it'll probably change. So, and we also want it to be accessible to the rest of the test. So say before async, say marketplace, lowercase equals await, capital M marketplace deployed. This is just like we did in the console, right? I just did this. And then that's going to get a deployed copy. And the first thing we want to do is say describe deployment. So describe is something that comes with Mocha. Say async. And I'm going to explain this async await that we see all over the place in just a minute. So say it deploys successfully. And we'll pass in async. I'm actually be consistent here, sorry. And we'll say const address equals await marketplace address. And now we want to say assert, all right, not equal address 0x0. So essentially what this is doing is just getting the address and saying, hey, we want to make sure that it's present, that it exists. It's not equal to this. And we also want to make sure it's not an empty string, that it's not null, and that it's not undefined. So we can also do that just like this. Boom. All right. So let's run this and see if it works. We can go to the terminal like this and say truffle test. All right, and this is going to actually run all the tests inside of our test directory. In this case, we only have one, so it should find that and run it. All right, see what happens. All right, there we go. It passes. Okay. So now, let's see here. Marketplace deployed. Works. Okay, so the next thing we want to do is just check that the name was set properly. Okay, we'll go back to our test, and we'll write a new one. We'll just say it has a name. Say it has a name. Say async. Say const name equals await marketplace name. Say assert equal name. We'll say Dapp University marketplace. All right. Let's save that. Run this test. And while this test is running, I want to go ahead and explain something. So you see this keyword async, and you see this keyword await everywhere. I did this in the console where I said marketplace equals await, marketplace deployed. So why do we need this await keyword? Well, deployed here is an asynchronous function call. So what does that mean? It basically means that it's going to, JavaScript is going to allow you to resume code execution while this function is still being called, right? It doesn't wait for this function to finish before it moves to the next line, okay? So, but if we use the await keyword, it does, all right? And you can only use the await keyword in an async context, okay? And that's why we had to have async here. So there's lots of different strategies for doing this. Essentially, this deployed function is asynchronous because function calls from the blockchain are asynchronous because it can take a long time. And so that's why by design it's asynchronous. But if you want to wait to get the smart contract from the blockchain, you have to do it. You have to wait for it. So that's why I use await keyword and async in context. So you'll see this is called the async await pattern, and you're going to see it all throughout this code base in the tests, in the console, and in the client-side application. Okay, so if I just wanted to stop and explain that here. You can read more about async await online. So, all right, our passed. So there we go. All right, guys. So that's it for this video. This is, the conclusion of the first video where we, set the whole project up. We're talking to the blockchain. We've got a basic smart contract. We've got tests ready to go so we can deploy the smart contracts with confidence, knowing that they work. And we can, continue writing tests and continue building out the smart contract in the next video, and that's exactly what we're going to do. All right, so before we do that, be sure to subscribe to this channel if you haven't already. Click the like button down below. And if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.